Hello, Legacy Sabers, Marsh here. So today we're going to be looking at graphing hyperbolas at the origin. You're going to want your conics foldable once more, and then I would recommend writing utensil and then maybe like 3 colored pencils or 3 colored pens or something along those lines. Again, for labeling of these diagrams. So, first of all, we need to talk about a hyperbola. A hyperbola is when we cut through a cone-shaped structure so that it's intercepting both sides of the cone. They basically look at 2 parabolas, however, they're on the same graph. First, let's talk about a horizontal hyperbola and all the pieces to it. First thing, of course, that exists, and I'll do that with a regular color, is the center of the hyperbola. Notice that the hyperbolas, okay, the parabola pieces, are not going through the center. They are just going through, the center is just in the middle. We have the vertices. That would be the first color I would mark with. The vertices are the dots of the hyperbolas or the parabola-shaped boomerangs of our structure. Again, we have foci or two focus. That sounds weird, but yeah. We have one focus on the right and one focus on the left. It's in between or in the middle of the parabola-shaped structure. And then our hyperbolas also have asymptotes on these graphs. So we have some asymptotes on the left and the right going on here too. So I would do a color for the vertices, a color for the foci, and then a color for those asymptotes on your drawing. The standard equation for a hyperbola that is opening left and right looks like the following. It is x minus h squared over a squared minus y minus k squared over b squared equals 1. So notice there is a subtraction sign in the middle there when we're looking at it. Looks very similar to a ellipse. The only difference is the ellipse had a plus and hyperbolas have a minus. So that is why definitely taking a look at that there is a subtraction sign there is what we're having to focus on. The formula for the foci. So how do you find it? Just like the ellipse graph, we cannot just identify the foci from our equation. So the first thing we need to write down is the equation. The equation to find foci is c squared equals a squared plus b squared. Yes, that is the Pythagorean theorem going on there. So what are the a, the b, and the c in our graph? Well, the a is how far your vertex is to a center. Okay, so this is my A value right here. Let me turn it to laser pointer. This is my A value right here. This value right there. The B value normally on an ellipse was a co-vertex, right? There's no co-vertices here. So our B value is going to be how far is your vertice to the asymptote. So notice I went up and down that B value. Unlike the ellipse as well, the A and the B do not have any structure behind them. So the A is not necessarily the bigger value, B is not necessarily the smaller value. And then the C is my center to a focus when I am looking at that. Lots and lots and lots and lots of lines going on here. So my A is always going to be a vertex to a center, my B is always going to be a vertex to an asymptote, and my C is always going to be a focus to the center. Lots and lots of identification going on here. And just like that ellipse, we also can look at vertical ones. So we've just looked at the horizontal. The vertical guy, notice the Y is showing up first in the problem. But notice the denominators have not changed. The first denominator is always going to be how far your center is to a vertex. Now, parts of a hyperbola that is up and down. Same pieces, no difference here. We have the center. And then with a new color, we have our vertices. And with another new color, we have the focus on the top and the bottom, the foci. And then, of course, we have those asymptotes crossing through. That would be the third color. Okay. So we're identifying all of that information every single time when we're graphing these guys. And then the final thing is the standard form of a hyperbola. Again, we still have that y minus k squared. Notice that is in the front now. So the y value, k, for the center will be in with the y, and the x value for the center will be with the x. So we're going to have to be very careful and make sure we identify that once we get into translated ones. Again, though, we do have the a value is right here. The b value will be right here. Okay? So the a value is always going to be under the first denominator. It doesn't matter who's bigger. It just matters who's under, the a is always going to be your first denominator on that. Just remember, asymptotes. Asymptotes are just linear equations that the graph of the hyperbola will not cross over. We looked at asymptotes when we talked about rational functions in this class. The graph will get very, very close, but it's never going to cross that asymptote. So just remembering, what does it mean to be an asymptote on our graphs? Let's try the very first problem. So, first thing I notice is we're not equal to 1. Notice this guy is equal to 1. So I need to be equal to 1. So let's divide everything by 36. Let's take care of that first. So I'm going to get x squared over 36 minus y squared over 4, right? 9 over 36 equals 1. Now, x shows up first. That means this guy is left and right. That is the way to identify. It doesn't matter who has the bigger denominator. It matters which letter shows up first in our equation. My center today, notice there's nothing with the x and the y, so we're going to have a center of 0, 0. No moving going on today. We're just going to identify these. My 0, 0, I'm going to put a center, little c on that. My a value is the square root of the first denominator, so that's my 6. B is going to square root of the second denominator. That'll give me 2. C, remember, is a squared plus b squared equals c squared. So 36 plus 4 equals c squared. So 40 equals c squared. Square root. I'm going to get 2 square roots of 10 is c. And as a decimal approximation, the square root of 40, 6 and some change is kind of where I would say that is. Let me get an exact here. 6.3 is what that is exactly. Approximate, exact. Now, let's identify everything. I'm going to go to a different color here. My vertices, I'm going to go 6 left and right from my center. So I'm going to go 1, 2, 3, 4, 5, 6. That's a vertex. I'm going to mark that. 1, 2, 3, 4, 5, 6. That's a vertex. And those ordered pairs are negative 6, 0 and 6, 0. That's what I'm going to get for those vertices there. Change my color again. My B value is going to allow me to graph from my vertex to an asymptote dot. So I'm going to go 1, 2, put a dot there. 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 And then what I'm going to do is I'm going to connect those dots through the center. So this guy is going to go like this. Okay. And then these ones. Okay. And then we'll write those equations here in a hot minute. Foci, that's my C value. So I'm going to go left and right because they're the same length, same direction as the vertex. 6.3. So I'm going to go to my new color here. Ooh, green. 6.3. 1, 2, 3, 4, 5, 6, and a little bit more. That is a focus. And then my focus other one will be right here. Now I can connect the dots or draw in my graph, my vertex. Notice I'm going to go towards the asymptote but not cross over it when I graph in my hyperbolas. Now, let's write the foci ordered pairs. I went left and right 2 square roots of 10. So I'm going to say I went left and right, plus and minus, 2 square roots of 10, comma, 0 is what I'm going to write there. Now, the asymptote equations. These are kind of difficult, kind of weird. I need 2 things to write an equation of a line, because that's what they are. They are lines, yes? I need a slope, and I need a y-intercept. Let's find this guy's slope first, because the y-intercept is 0, 0, right? I went, for slope, rise over run, I went up 2 over 1, 2, 3, 4, 5, 6, right? 2 over 6, which is the same as 1/3. So I did positive 1/3 x for my equation. The other guy, I went down 2 over 6. So I have a negative 1/3 x for the other equation. They always will be the same slope. One will be positive, one will be negative. That is the coolest thing about these when you're identifying, is that your slope, one will be positive, one will be negative when you're actually graphing these things out. Let's try the second example. Again, we're not equal to 1, so let's make ourselves equal to 1. Let's divide by 100. So I'm going to get y squared over 4 minus x squared over 25 equals 1. Now, my y is showing up first, so that means I have to go up and down this time. My center will be 0, 0. So let's put that in there. Beep, 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 center. My a value is going to be the square root of the first denominator, so that's going to be a 2. B is going to be the square root of the second denominator, 5. Again, notice the a is not the bigger number. It just depends on who is first. My c value, we're going to subtract or add the numbers. So we're going to go 4 plus 25. That's going to give us 29. Square root that. 29 doesn't have a perfect square. It is approximately probably 5.4, roughly. Yeah, 5.4. Okay. Now, let's figure out where all this stuff is. My vertices, I'm going to go my a value, because remember my a on a hyperbola is how far my center is from a vertex. And I got to go up and down this time. So I'm going to go up 2, put a vertex down, down 2, put a vertex down, okay? Those ordered pairs would be 0, 2, and 0, -2. Those would be those ordered pairs. Now let's do my b value. My b value is how far my vertex is to a point on my asymptotes. So I'm going to go left and right on my vertex, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Same thing through this one and this one. Now I'm going to connect that through my center. Notice it's a dashed line. That is because it is a asymptote. Okay. Almost there. Then, I guess we could write the equations of those right away. My slope looks like it's up 2 over 1, 2, 3, 4, 5. So my equations, y equals plus or minus 2/5 x are those asymptote equations there. And then my c value, I'm going to go 5.4 up and down. So I'm going to go right here. There's a focus. And that's the other focus. Let's draw on our graph. From my vertex, I'm going to go really, really close to those asymptotes. Like that. The foci ordered pairs then, I went up and down square root of 29. So 0, comma, plus or minus the square root of 29 for my ordered pair there. And that is the end of this video. These hyperbolas are a little funky. They're a little different compared to the asymptote or compared to the ellipses that we've been looking at and the other conics we've investigated. But with practice, they are quite a easy graph to do. You just need to remember what the A value and the B value and the C value all mean in regards to our hyperbola. And until I see you in class, I will see you later, Savers.